Okay, so we did that simplifying radicals worksheet after the quiz yesterday. A radical is any square root or cube root or fourth root or fifth root or anything like that. An entire radical would be something like the square root of 47 or the cube root of 18 or even the fourth root of 25. When you have the entire number inside the radical, we call that an entire radical. A mixed radical is when there's a number in front. So if we would say 2 root 2's with a number in front, that would be a mixed radical. Or 3 cube roots of 5, that would be a mixed radical. So if there's a number in front and a radical, then we call it a mixed radical. So what we have to do to simplify a radical is we have to change entire radicals to mixed radicals. And one of the ones I showed you yesterday was the square root of 8 is equal to the 2 square root of 2. This side we would call simplified. Another example could be the cube root of 16 is equal to 2 cube root of 2. And that side would be considered simplified. So the way that we do this is we look for either a perfect square or a perfect cube, depending if we have a square root or a cube root, inside that divides the number. So for example, if I would take something like the square root of 54. What are numbers that divide 54? 2, 6, 9, 27. So when you go through those numbers that divide 54, 2, 6, 9, 27, 54, 1, are any of those perfect squares? 9, because 9 is 3 times 3. So we know that 54 is 9 times 6. And because 9 is a perfect square, and what we learned yesterday is the product of two numbers inside a square root is equal to the product of the square roots, we could write it like this, and now we could simplify, because the square root of 9 is equal to, what's the square root of 9? 3. And now we have this simplified, because we've changed it from an entire radical to a mixed radical. Let's do one for cube roots. Let's do the cube root of 32. What are numbers that multiply to get 32? 2 and 16, 8 and 4. Is that it? 16 and 2, 1 and 32. Are any of those perfect cubes? 8 is, because 8 is 2 times 2 times 2. So we could rewrite 32 as 8 times 4. And the same thing is true with cube roots. That is true with square roots, that you can multiply them. And the cube root of 8 just becomes 2. And this is simplified, because it's written as a mixed radical. So one of the things you need to be able to recognize when simplifying is not only what numbers multiply to give you something, so you see 54 and have to think of all the numbers that multiply to give it, but you're also trying to find those perfect squares or perfect cubes. So here's a list if you don't remember them. All right, let's estimate the square root of 79. Between what two whole numbers will the square root of 79 be? Between 8 and 9, and you know that because 8 is the square root of 64, and 9 is the square root of 81, and the square root of 79 is about there. Be closer to 8 or closer to 9? So what would you say is an estimate? 8.9? Sounds pretty good. So that's just how you would estimate on a non-calculator part. You would have to know your perfect squares so that you could figure out that it's between 8 and 9. And then in this case, it's closer to 9. We're going to simplify the following. Simplifying, again, this is a key word. This is probably the most complicated math word there is for instruction, because the word simplify has about 15, 20 different meanings depending on the math question. So it's not a really simple word, it's more complex. Simplify for radicals so far means write as a mixed radical. So if you see the word simplify and it's a radical question, you now have to know that simplify means write as a mixed radical. Where else have we seen the word simplify? Fractions. What does it mean for fractions? Put it into lowest terms, right? Where else have you seen simplify? Algebra. What does it mean for algebra? Combine the like terms, right? So we've seen simplify for algebra. It means combine like terms. Simplify for fractions means put in lowest terms. And simplify for radicals means write as a mixed radical. How would you break up 63? 9 and 7. Square root of 9? 3. So now we're left with 3 square root of 7. Be careful. This happens to a lot of people. This is a mistake that a lot of people make. They do square root of 9 times square root of 7. That's good. They say, I know the square root of 9 is 3. The next thing they write is square root of 3. Because you're so used to writing square roots, you just keep writing square roots. So be careful. Check yourself if you start doing that. It should just be 3 root 7. But you get so used to writing so many square roots that you just keep writing them. So that's one thing to be careful of. Now we've got 108, and it's a cube root. So now you're looking at your perfect cubes. What divides 108? 27, and it's 27 times. So 27 times 4. And the cube root of 27 is 3. Now we didn't make a list of perfect fourths, so we can do it now. What is 2 to the power 4? 2 times 2 times 2 times 2. 16. What is 3 to the power 4? 3 times 3 times 3 times 3. 81. Now question, when you were doing 3 times 3 times 3 times 3 in your head, when did you get stuck? Were you good at 3 times 3 and got 9? And then you did times 3 and got 27? And then you were stuck for a bit? Okay. Can you see that you can make this easier if you do this and this first? Those will both be 9. What's 9 times 9? 81. That's easier than going through and doing 3 times 3 times 3 times 3. The nice thing about when you get to perfect fourths, you've got 128. I hope you can see right away that it's not going to be 81, because 81 times 2 is already more than 128. So when you're checking these, it's going to have to be 16 if it's going to work. 16, if I was doing this mental math, what's the only number that you times a 6 by that you can get an 8 at the end? 6 times 8 makes 48. So in this case, if I'm checking 16, 6 times 8 is 48, 6 times 10 is 80. 80 plus 48 is 128. So this is equal to 4th root of 16 times the 4th root of 8. Fourth root of 16 is 2 times the 4th root of 8. So here's a couple for you to try. One reason I really like the first example for square root of 72 is because there's 2 perfect cubes, perfect squares that will divide it. How many people thought 9 times 8 first? Okay. How many people thought 36 times 2 first? So we'll do both of those and see what happens. If you thought 9 times 8, it would look like this. And if you thought 36 times 2, it would look like this. Square root of 9 is 3. So then I'd have 3 root 8. Square root of 36 is 6. And I'd have 6 root 2. Now our answers are different right now. So the question is, which one is simpler? Because when we write it in simplest terms, we need to write it as a mixed radical, and they're both written as mixed radical, but one is in a simpler term than the other. And we would say that this on the right is in a simpler term because square root of 8 can still be divided by another perfect square. Because 8 is 4 times 2. So it wouldn't be wrong if you chose 9 and 8. It'll just take a little bit longer. Square root of 4 is 2. And 3 times 2 makes 6. So we do get the same answer. It's the same thing for simplifying fractions. If you had something like 48 over 32, you could simplify that by dividing both by 2 and get 24 over 16. And that would be simplified, but not completely simplified. You would have to keep going, right, until you got it to lowest terms. Same thing happens with radicals, right? Same thing happens with radicals. You have to keep simplifying it till it's a mixed radical in its lowest terms, until there are no more perfect squares or perfect cubes or whatever the radical is inside in there. So if you see the biggest perfect square, that makes it the fastest, right? If you could have seen with this fraction to divide both by 16, you would get to 3 over 2 the fastest. But sometimes seeing that biggest one isn't easy, right? So it's not wrong to start with the smaller one, like 9 and 8, and get 3 root 8, but then check inside your radical. Is there another perfect square so I could simplify it further? Cube root of 32. The biggest cube root is 8. And you're left with 2 cube root of 4. The other thing that you're going to have to really pay attention to for details here is you're used to square root signs, you're not used to cube root signs. You might be very tempted when you see cube root of 4 to say that's 2, because square root of 4 is 2. So you just make sure that you're ready for those kind of things. Okay, 2 more. Try those 2. .48 is 16 times 3, and the 4th root of 16 is 2. So this one simplifies to 2 4th root of 3. Square root of 30. What perfect square divides 30? Nothing. There's no nice numbers that divide 30, so this one we would say is already in the simplest form. So when you get a number like 30, instead of just thinking of all the things that multiply to 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6, and checking if any of those are perfect squares, it's a better strategy to go to your list of perfect squares. And since I'm dealing with 30, if it's going to work, it would have to be one less than 30, right? Well, obviously it's not going to be 25, because 25 times 2 is already too much. 16 times 2 isn't 30. That's too much. 30 can't be divided by 9. 30 can't be divided by 4 to get a whole number. And so just checking those ones would tell you that it's already simplified. The other thing you do is you take your mixed radicals, and there'll be sometimes that'll be important to change mixed radicals into entire radicals. Because well, I'll show you an example in a bit where that would be helpful. We're going to get our quizzes back. I don't know if I recorded this part or not. There it is. There's the work. There's your homework. You can write that down, and I'll hand back your quizzes.